Hi yo, this is Andrew, and today we'll go over the booster paper E1. Section A. Question 1 is about basic coordinate geometry. We want to show the angle between L1 and L2 is 90 degrees. So, to do this, we need to show that the product of the gradients of lines 1 and 2 is -1. Let's find the gradient of line 1. y2 minus y1, x2 minus x1. That will give you 2. M2 is equal to -1 by 2 because we can rewrite this line as y equals to 13 minus x divided by 2. And the slope is going to be -1 by 2. Thus, m1 times m2 is -1, and therefore m1 is perpendicular to m2. Oh, sorry. Therefore, the two lines are perpendicular. The angle between them is 90 degrees. Part B. L3 is perpendicular to the line x equals to 7 and passes through the point of intersection of L1 and L2. Let's break down the problem. First off, we know that it is perpendicular to x equals to 7. That means you have a horizontal line, y equals to something. Secondly, it passes through the point of intersection of L1 and L2. So we need to find that first. Point of intersection. We found the slope of line 1. So from that slope, we can then find the equation of line 1. Y minus y1 is m times x minus x1. We know the equation of line 2. So from there, we can find the value of x and the value of y. So plug equation 1 into equation 2. And therefore, we can write down the value of y. So the point of intersection is 3 and 5. We know that the line y equals to a constant passes through the point 3 and 5. Therefore, line 3 has equation y equals to 5. Question 2. In this question, you're given a normal distribution with mean 0 and standard deviation 2. The notation is n mu sigma squared. So let's quickly sketch this out. We have a normal distribution. It is given that the probability that x is greater than 2 is equal to a, and the probability that x is greater than 4 is equal to b. The probability that x falls between 2 and 4, it's gonna be this tiny segment over here. And this segment is going to be a minus b. Plain and simple. Part B. The probability that x falls between -4 and 2. Where's -4? -4 would be all the way over here. Because of symmetry, we also know that the probability that x is less than -4 is equal to b. The part that we're interested in is from -4 to 2. So this probability is equal to 1 minus A minus B. This blue segment over here is A. This brown part is B. The sum of the entire probability line is 1. So this green part over here has to be 1 minus A minus B. And this is the end of question 2. Question 3. Show that dy by dx is this expression. We have a product of two functions, so we are going to use the product rule. I can write this in a somewhat nicer way before we start to differentiate. Okay, y prime is equal to the derivative of the first term times the second term plus the first term times the derivative of the second term. We are now going to add the two fractions. Multiply square root of x minus 3 to the first term. Notice that the 2 is in the denominator. So let's factor out 1 by 2 from the numerator. And now we can shove this 2 into the denominator and finish the proof. In part B, you're then asked to use that result to integrate. So let's divide the integrand by 2 and multiply it by 2. The reason is that we want to make sure this guy matches the derivative. We know that the derivative of this function is your dy by dx. This is your dy by dx. Therefore, by integrating this, you shall get y. Upper bound, lower bound. Let's replace y with the actual expression. Upper bound, lower bound. And you will get 42 as the final answer. Question 4. We want to find the term that is independent of x. In other words, the constant term in a binomial expansion of this guy. So let's write down the general term. The general term is going to be 12 chooses k, x cubed to the k, minus 1 divided by 2x to the 12 minus k. You can use your formula booklet for this. We want to find the term that is independent of x. In other words, the term x to the 0. So let's simplify this expression a little bit. X cubed to the k, that's x to the 3k. Negative 1 by 2. x to the power of 12 minus k, that is negative 1 by 2, to the power of 12 minus k, x to the power of negative 1 to the power of 12 minus k. We know that 3k minus 12 plus k has to be equal to 0. So k is equal to 3. So the coefficient is going to be 12 chooses 3 minus 1 by 2 to the 9. 12 chooses 3. You can use Pascal triangle for this, but it will be very complicated. Or you can use the binomial definition. So n chooses k is equal to n factorial divided by k factorial n minus k factorial. Therefore, 12 chooses 3 is 12 factorial divided by 3 factorial times 12 minus 3 factorial. Negative 1 by 2 to the 9, that's negative 1 over 2 to the 9. We should not simplify because 128, that's 2 to the 7. So we'll find ways to simplify this expression as much as possible. 12 factorial is 12 times 11 times 10 times 9 factorial. We stop at 9 factorial because we want to cancel it with the 9 factorial in the denominator. 3 factorial is equal to 3 times 2 times 1. Twelve is 4 times 3. 11. We have 10 over here. So let's make it 5 times 2. 4 is 2 squared. 128, that's 2 to the 7. So let's simplify the 2 as well. And you'll be down to minus 55 divided by 2 to the 7. So A is equal to negative 55. Not too bad, eh? Question 5. You're given that 5 sine squared minus 3 cos squared is equal to 7 sine of 2a, and you're asked to show that tan a is equal to 3. Tan a, that is sine of a over cos of a. So the logic, the thinking is that we shall divide both sides of this equation by cosine squared to see if we can simplify it even further. Sine of 2a, that's 2 sine a cos a. Divide both sides by cosine squared. Now you have a quadratic equation to solve. Factorize this guy. Tan a is equal to 3, or tan a is equal to negative 1 by 5. We know that a is between 0 and 90. On this interval, tan a has to be positive. Because if you recall, pi by 2 is the vertical asymptote of the curve y equals to tan of x. And the curve is going up. Therefore, this cannot be the value, and tan a has to be equal to 3. You must include an explanation for this. Part B. Explain whether sine of 135 plus a is positive or negative. Okay, interesting. Let's start off with the graph of y equals to sine of a. We know that a is between 0 and 90. So 135 plus a is going to be between 135 and 225. The question is, where exactly does it fall on this purple piece? And we want to compare 135 plus a with pi. Tan a is equal to 3. This is greater than tan of 45. And we can see from the graph that the graph of y equals to tan of x is monotonically increasing on the interval 0 to pi by 2. Therefore, a has to be 345 degrees. Therefore, a plus 135 degrees is greater than 180 degrees. And sine of a plus 135 is therefore negative because we showed that it has to be on the green part. Question 6. We want to find the values of m so that the function g of x is always increasing for x in R. So, always increasing, that means the derivative has to be positive for OX. G prime is 3x squared minus 12x plus m. The function is always increasing. So let's consider the possible cases here. The coefficient of x squared of g prime is 3, positive. So we know the parabola is opening up. We can also deduce the coordinate of the vertex, the y coordinate rather. It has to be equal to 2. So the parabola either looks like this, like that, or like that. It has to be increasing for all x in R. That means that it has to be in the first scenario. That also means that this quadratic has no real roots, and thus delta has to be less than 0. Delta is b squared minus 4ac. B is negative 12. A is equal to 3. M is equal to C is equal to M. And this is the end of question 6.